Hello, everyone. Thank you for the kind introduction. Thank you for the opportunity to talk to you here at this really fascinating conference. Can you hear me well still? Okay. Just noticed that I forgot to put the author names on the slides. This gives me a good opportunity to mention that the work that I'm talking about here is a collaborative effort. And together with me, my colleagues Andreas Schubert, who cannot be here, worked on it, and also my colleague Stefanie Steinhardt, who is sitting over there. So if you have questions after the talk, please address those either to me or to her or to both of us. As you mentioned, I joined university a couple years ago after having worked for 12 years as technical writer. Besides that I love teaching, I really enjoy the privilege at the university to spend a little more time on, say, scientific efforts, that I think are necessary to make documentation better. When I talk of scientific efforts, I'm not referring to those activities that are primarily devoted to making theoretical advances. Those efforts are important. My interest is more into those efforts that kind of allow to derive recommendations that are of relevance to the practitioner, right? And there's so many issues that come up in the day-to-day work. Just one example, we yesterday heard that talk about screenshots in software documentation, and there were some suggestions on what you can do to optimize screenshots in terms of the size of the screenshots and in terms of using means to direct the attention of your user to the relevant parts by, for example, using a magnifier, stuff like that. So all these optimization efforts mean cost and mean resources and effort that you have to put into that. And what you want to know, I think, is, for example, to convince your manager whether these costs are justified, is whether these efforts do have a positive effect in terms of that the user can more efficiently and more effectively work with a user guide that contains optimized screenshot, for that example. So work that really fascinates me is that of John Carroll, for example, whom you all know, who is the inventor and the proponent of the minimalist design principles. And from the very beginning, he also kind of complemented his work with scientific endeavors, scientific investigations that were aimed to prove that minimalism is not just a set of plausible principles, but actually something that produces better manuals, that serve the user better in terms of more efficiency and more effectiveness. Okay, the question that we take up at our research group these days is the question of API documentation. I don't have to explain to you what APIs are. You know that APIs grow more and more important these days. API documentation has also gained a lot more interest in recent years, and there's in fact also a lot of literature that has been produced and that has revealed some results showing that we apparently have not yet understood exactly what API developers want. For example, there's an interesting study by Robillard and Deline. They did an interview study and a questionnaire, and they asked developers, what are your most severe obstacles when learning a new API? And they found out that besides many, many problems that you can have, like lack of relevant domain-related background knowledge, it appears that insufficient documentation, a lack of adequate documentation resources is, from the perspective of the developers, the most severe learning obstacles in terms of getting into new APIs. In a similar vein, there's a study by Chris Parnin. He kind of observed what Android developers are using when they have questions. Do they use the official Android documentation, or do they turn to other information sources? And what he found was that they almost always turn to forums like stackoverflow.com, and in proportion to that, only rarely use the official Google documentation. Similarly, Lethbridge and colleagues, they monitored the activities of developers across a day or two, and they kind of categorized these activities, whether the developers were coding or involved in organizational activities or doing some research using documentation. And what they found is that only 3% of the activities of the developers were related to kind of using documentation. And finally, an interesting study by Malik and Robillard, they kind of they investigated the API references of the JDK and .NET APIs and kind of tried to classify what type of information do the individual pieces of text contain. Are they kind of more procedural in nature? So do they instruct the user to do something? Are they more descriptive and explanatory? And for about 40% of the information, they were not able to classify them at all. So they termed that non-info, right? So merely repetitions of method names, class names, parameter names, stuff like that. So 40%, that's quite a lot. So it seems, and quite interesting, although typically developers kind of write API documentation, or at least provide the basis for API documentation, we still haven't really understood what the information needs of developers are. So perhaps developers are not the best in kind of anticipating the information needs of their own peers. Okay, we kind of tried to take that up and to explore information needs of API or of software developers using APIs in a more systematic way. And yeah, these are some general research goals that we pursue. We want to know kind of which strategies developers follow when they get into a new API, which questions they raise first, which questions come later, how the developers use API documentation, if they use it at all, right? Which information they look for, and also which kind of quality criteria the developers apply to API documentation. What do they regard good or bad documentation? Our strategy is to collect data on these issues and then try to think, okay, which kind of consequences could be derived from that, and which kind of consequences can we derive from these findings to improve API documentation. I will briefly report on the results of 3 studies. We did an interview study, a questionnaire as a follow-up to that interview, and an observation study. The interview study had the goal to kind of first explore the field. We were not able to derive any specific hypothesis in the beginning. The questionnaire study was designed to kind of validate the statements we distilled from the interviews and to see whether we can kind of rank them, whether they differ in terms of relevance and so on. And the observation study kind of took a different perspective. Instead of asking the developers what they expect and what they regard useful and helpful, we kind of observed them while they were performing some programming tasks that we designed for them. And we kind of monitored which documentation resources they were using. Okay, first to the interview and the questionnaire. As I said, goal of the interview was to kind of first do a qualitative exploration of the field, collect feedback and stuff. And the questionnaire then was designed to validate the information we found in the interview. For the interview, we used the technique of semi-structured interviews. Our goal was to kind of get a conversation going. Yeah, so, and as you may know, if you regularly talk to developers, and if you are a developer, please forgive me, but developers tend to be not the ones who kind of expressively engage in a conversation and reflect on what they're doing and would like to share that with you. So we kind of constructed a set of questions that we termed trigger questions and were designed to kind of elicit information, give them a starting point, you know, to talk about certain things we were interested in. Okay, the interviews lasted about 1 hour. We had 23 developers in total from 4 different companies with varying background and varying level of programming experience. The follow-up questionnaire, we constructed 39 questions, typically questions of the type, well, you know, here's statement A, and please rate the relevance, the helpfulness, the importance on a scale of 1 to 5. Or another type of question where we provided several options and asked participants to select 2 or 3 out of those options we offered. And those options that we offered were typically derived from the interview. So we did not think up that for ourselves. We tried to kind of relate that back to the interview we had been doing before. We had 113 participants in that questionnaire that we posted online. average professional experience of the participants was 12 years, that was the mean, and the median was 10 years, splitting the group into equal halves. As you can see, a few more males than females participated. We had developers with different roles, so software engineers, team leads, testers, and so on, and almost all were native speakers of German because we kind of distributed that survey only across channels that we accessed from Germany. All right, so now first a couple results from the interviews that we conducted. We were initially interested in, as I said, learning strategies, approaches when you have to get acquainted with a new API as a developer. So we asked, okay, which questions come up first when you learn a new API? What questions come to mind? And here's some answers that we got. Questions like, what can I do with the API? So which features, which purposes does it serve? Which features does it offer? How do I get the API up and running? How do I program with the API? How can I test the code? What is the basic API architecture? And what you can see is some are more practical, some are more conceptual in nature. The interview did not allow us to kind of bring that into a kind of ranking, to decide, okay, is there any difference regarding importance, relevance? And therefore we kind of took this up in the questionnaire and asked people to rate or to let us know which questions they come up first, second, and third. This is now the result from the questionnaire, which took that up and asked which question do you raise first when you approach a new API. And here you see a clear winner in terms of how often this answer option was selected. So what can I do with the API? What are the features, the purposes of the API? That seems to be initially of most relevance for those who are new to an API. For the second question on this slide, there's no clear winner, but say two who kind of rank first. Again, a more conceptual question like basic API architecture and API structure. And secondly, how to get the API up and running, so more practical question then. And for third, now here come the more specific programming questions. How to program with the API and how to implement my special use case are the winners here. So beyond the question that almost everyone seems to have, like, okay, what is the API doing and what purposes does it serve? Then it seems there's a more, say, conceptual road, more interest for a certain proportion of the population we tested in concepts, in things that help you develop a thorough understanding of the API, and for the other half or the other portion of the population we tested, it's more practical questions. They kind of seem to strive towards the goal of getting into action as soon as possible. And this is exactly this kind of activity-driven, code-driven strategy that we expected to dominate by far, but it didn't dominate by far. We then also asked, okay, beyond the questions that you raise first, second, third, which activities do you engage in when you start to get into a new API, when you start learning it? Here's some answers for one group that seems to show a pattern of more kind of concepts-oriented, systematic approach. Pretty good expressed by the quote that we translated here into English. I first need a global understanding of the API and details will follow later, right? The other group, here the quote is, I'm writing code and therefore I'm looking for code. So those are not looking for, say, conceptual information. They look for samples, for code. They want to see how the code looks like. They want to get a feel for the code. And they do check the documentation only if they don't find a solution on their own. Okay. Now, again, we subjected that into the questionnaire, and what we found is that two options kind of rank first. So the more action-oriented, code-oriented option, I work through some sample code of individual API functions that was selected most often. And I really getting started document is the second. And if you group those activities into those indicating a more concepts-driven approach and into those that indicate a more code-driven approach, then we found this is not exactly, but it seems to be fairly balanced, although the more concept-driven approach seemed to have a slight advantage here as well. Okay, the typical problems when you start learning a new API. Here again, in the interview, several things were mentioned: technical issues with the API, difficulties with the API infrastructure, background knowledge that was missing, blah, blah, blah. And to our surprise, the documentation-related issues apparently ranked on top. So in line with Robillard and Deline, for example, we found that wrong or incomplete documentation and incomprehensible documentation seem to be the topmost problems that developers encounter when they get into a new API. What do you expect from good API docs? They need to be up to date, should be complete, not surprisingly, include code samples, and also detailed explanations for classes and methods. In the similar vein, we asked what are typical issues with API docs, and here the answers given primarily were unclear content structure navigation. So navigation seems to be a very important point, as also confirmed by our observation study. The documentation structure is too complex or the language is incomprehensible. The final result I would like to show, if that's going too fast, you can approach me later and take some more photos. Okay, we wanted to know which information sources do you use, preferably, and we then split that up into two different usage contexts, like initially when you kind of start learning, and later on when you are familiar with the API and have to solve some programming task. And the blue bars here represent the answers that were given for the usage context. I'm getting into the API, and the green bars represent those for I'm solving programming issues later on. What you can see here, initially, sample code is of greatest importance. Tutorials play a major role. The API reference is used at this stage as well. Later on, when you are more familiar with the API reference clearly takes the lead. Then forums are also very important, and sample code loses a little bit in terms of relevance. All right, I'm skipping over a few things here. The results we draw from the interview questionnaire studies. Basically, there's two kind of strategies that we can observe. Concept documents tend to be ignored if you kind of, I forgot to mention that, tend to be ignored if you present concept information in just one atomic block, right? You need to spread concept information across, say, tutorials or the API reference. Even those who are interested in concepts tend to ignore that. Sample code is important. The API later on is the main information source. All right, a couple minutes left for the the observation study, which we basically did to kind of confirm 10 minutes, cool. Things that we have found in the interview and questionnaire study. Why did we do that? Okay, what people say they do and what they actually do is not necessarily the same. You may have noticed that yourself. We also found that our interview partners very often said, well, oh, okay, I actually haven't even thought about it, so let me think. And then they kind of generated some answers, but that's okay, no problem. But therefore we said, okay, let's do a complementing study that observes programmers while they are working. Yeah, so that sounds like a laboratory study. No, it was not. It was kind of controlled in the sense that we designed questions, programming tasks, but we went to the companies where we recruited our test subjects. They were working in a meeting room, so it was, say, semi-controlled. Yeah. Okay. Yeah, which procedure did we come up with? We worked together with a partner, an API supplier that is an REST API. It's connecting web shops to, it's kind of a proxy that connects web shops to various shipping suppliers, shipping services. We came up with 5 tasks. The developers were allowed, but not encouraged, specifically encouraged to use the documentation. We had 11 participants. The test ranged about 1 hour. The fastest were about 35 minutes. And after 75 minutes, we just made a cut. And there were 2 developers who were not able to complete all the 5 tasks in that time frame. We recorded the screencast with audio, and we also recorded the eye tracking. You may have heard of this technology. Eye tracking is a very sophisticated technology that allows you to monitor exactly where people are looking, and that helps a lot to understand, okay, which portion of a page attracts their attention. And afterwards, everything was coded. The videos were analyzed using Interact. This is the welcome page of the development center that we used as a test object, and they provide here various sections with different types of information. They have, of course, an API reference. They have another section that you can reach through the main navigation bar with recipes, with samples, with concept information, and with information related to integration, API integration. Okay, so let's see whether this works. This is an eye tracking video, just to give you an example how this looks like. What you will see is the ShipCloud web page, and then a red circle that is indicating where the people are, where this individual participant is looking at. Let me check. I can't see it on my. Oh, yeah, you can see it here. This is normal speed. You see they are inspecting the navigation on the right-hand side, and then they go into the API reference here and looking into other options. Clicking into the concepts page. Now you see they are checking the headlines, right? The headlines only, and then stop in code blocks. They don't read, actually. So they kind of scan, really in the literal sense. They scan, and again, code is attracting attention along with headings and with items from the navigation bar. So we did not attempt a quantitative analysis here, because we had a lot of data loss, because this was not a laboratory setting. We wanted people to move fairly freely, to behave as natural as possible. But we used that to kind of better categorize which sections of the documentation people looked at finally, and we used this software for that. So in the final minutes, a few results. This is the total time spent in the documentation pages versus the non-documentation areas. Non-documentation means editor, console, postman, if they use that, stuff like that. So things they needed to kind of accomplish the tasks, right? And as you can see, about 50%, that's the gray area on the left-hand side, was non-documentation related, but 50% was documentation related. So documentation pages. What you can also see, Uppsala, does that work? Yes. Okay, this is API reference. This is samples, recipes. These small bars here, this is the welcome page, and not surprisingly, I mean, they look at that initially and then go on. And this is the green one here, integration page, that was not necessarily at all. But what you can see is those pages offering sample code, namely the recipes and the sample pages, had the largest proportion of usage, right? And then API reference, and then concepts ranks last. So this is kind of in line with what we found in the interview study. What you see here is now, again, same split of data, but now a different kind of way of showing it. You see the total reading times individually for each participant, and we want to see, is there kind of a pattern that we see? And I think we do see a pattern, namely that you have two groups, the fast ones and the slower ones, right? And with one or two exceptions, it seems to... What should I do? Back? Is that better? Oh, sorry. There seems to be a split into two groups. You have the fast ones, the slow ones. The factor that determines whether you are fast with this task or slow is not programming experience, as we expected initially. What seems relevant here is the domain-related background knowledge. So that application, the API, was about an e-commerce related task, and so those who had some background knowledge on e-commerce tasks, you just were able to use that and to kind of got faster to the goal they had to reach here. Whereas those, even with a long programming experience, if they did not have that relevant domain-related background knowledge, they took longer time. And now, another slide. What's showing this? Now we scaled the reading time to 100% for each participant. This allows us to kind of estimate what is the relative proportion of documentation usage. And what is interesting here is you have a couple who read concepts and a few who really ignore the concepts altogether, right? And again, so if they have kind of read proportion in that they are concept readers, and if they don't, they are concept ignorers. So in line with the finding from the interview and questionnaire study, we have these kind of two groups. And again, what is the factor determining whether they read concept or not? It's not programming experience, and it's also not domain-related background knowledge. Perhaps, yeah, besides many individual factors that might be responsible here, the perceived complexity of the task. That was our impression, is the relevant factor distinguishing that here. And now the final slide, the final diagram. What about how does kind of documentation usage change over time, right? So with the first task, the second, third, fourth, fifth. So if you gain more experience, if you get more familiar, I mean, we're talking about 1 hour, right? Okay, this is limited, but anyway, two things emerge out of this. Here you see 2 tasks, 2 and 5, that have a huge share of sample code related pages that were used. For those tasks, the developers found there kind of a code template they could use right away. And if they found that, they kind of got stuck into that page and never returned to any other page, right? But if you ignore those, if you leave those out, you see indeed kind of a pattern showing that, yeah, the relative importance of the API reference kind of increases, so people tend to look more into that area with growing experience. All right, some qualitative results. As I said, developers don't tend to read, they scan, but in that respect they are like every other user that is reading information online. A clear and transparent and consistent navigation is very important. What we've also found is the navigation perhaps should better use not document types as main categories, like here concept information, samples, API reference, because developers don't tend to kind of categorize their problems in those terms. I have a problem and I'm not quite sure, is that now a concept problem? Is it something where I need a sample or go to a recipe section? They just want a solution, and I think they're better served. That was the feedback from that study, if you use more a content-based classification in that occasion here, for example, like something like handling shipping addresses, handling suppliers, stuff like that, right? Yeah, also what we found is code is also important in that sense that almost every line of code the developers produced started from some code sample, so they just didn't from scratch. They found something that could serve as a basis and used that and then continued. And a powerful search is important. That search was lacking on this page we investigated. Okay, I'm running out of time. I will just perhaps go on for 4 very brief general conclusions. Developers want API documentation with information that's easy to find, easy to understand. They should, API docs, like all docs, be produced by professionals in a professional way, because this is what developers demand as well. You have to reckon with different learning strategies and provide flexible offerings for those 2 learning strategies. I do think we can also conclude that kind of these experimental techniques can provide some value. And what I also think is we need some sort of theoretical basis to continue with this kind of research and to derive more specific hypotheses. So I hope you did not expect that we would discover the ultimate hidden secrets of API documentation. We didn't find those hidden secrets. We didn't develop the 5 golden rules that would kind of in a foolproof way lead you to the perfect API documentation, but perhaps some data that are worth considering for your next project. Thank you for your attention.